Hello everyone, this is Revati working as an assistant professor in the Department of Information Technology from SNS College of Technology. Welcome to our Data Structures and Algorithm class. In today's session, we are going to clearly understand about the tree traversal, which is one of the most important concept in the Unit 4 tree ADT. By the end of this session, we will know what a traversal is, then what is the important in our real-time application, and how to perform a breadth first search and depth first search in detailed manner, which is including pre-order, post-order, and in-order traversal. Let's begin to the topic. Before moving into traversal, let's quickly recall the structure of a tree. Already we know that a structure of a tree is having one root node and internal nodes and leaf nodes. Each child of a node forms its own subtree. That means a left subtree and the right subtree. And nodes exist in different levels starting from the level 0. The level 0 which is having root node. Understanding this layout will help you follow the traversal easily because simply means visiting each node exactly one in particular order. Here is the tree which is having three levels. The root is at level 0, S and T, that means intermediate nodes. It is also called as internal nodes, which is in the level 1, and the X, U, V, W are the another level nodes which is in level 2. Y and Z are leaf nodes which is in the level 3. Then let's we move on to the uh, our today's topic, which is tree traversal. Traversal is one of the most common operations performed on the tree ADT. It is simply means visiting each and every node in the tree at least once. And we have two different types of visiting orders, that means depth first search and breadth first search. Depth first search is having another three categories, which is pre-order, post-order, and in-order. Let's we see these concept in our next slides. Then breadth first search, it is also called as level orders, which will be discussed in the previous slide. Then next we will see about breadth first search. Actually, here the example tree is given. The 7 is the root node, which is in the level 0. It will be visited first. Then the level 1, 6 and 10 nodes are there. It is also called as internal nodes. The 6 and 10 will be visited next. Actually, the breadth first search will follow the concept of queue. Already we know that queue is following first in first order. Here the 7 is inserted in the queue first. It will be visited first. Likewise, it will follow the same logic up to 3 and 5. 3 and 5 are the leaf nodes which is visited at last. Then next is we will next we will see the difference between queue and stack. Actually, the queue is following first in first order. The breadth first search will follow the logic of queue, and the stack is following last in first order. That means up to last level we have to visit. That means the left last uh, leaf nodes will be visited first, and it will be following the backtracking method, and it will comes to right subtree. This is the example for breadth first search using the concept of queue. The NQ will be uh, done in the root node, that means alpha. Next will be gamma and beta. Likewise, we have to visit up to last leaf node. The steps will be uh, followed. Up to 13 steps it is having. Uh, the steps will be in the right side. The output of the visiting order will be in the middle. Then the queue will be at the last. The queue operations will follow the first in first order. The node which is enter into the queue will be visited first. At last we have to visit the last leaf node. Then next is the depth first search. Depth first search is nothing but categorized into three types: pre-order traversal, in-order traversal, then post-order traversal. We will explore these concepts in our next coming videos. Uh, Thank you so much for watching.